Yeah, welcome back, friends. Yeah, now we are uploading Rust programming inside out, chapter 3 of 41. Already we uploaded Rust programming inside out, chapter 1 as well as chapter 2 in the last 1 week. So today we are actually uploading Rust programming inside out, chapter 3 of 41. In this video, we are discussing mainly variables and mutability, concepts like variables and mutability. The difference between variables and constants. We also discuss a concept called shadowing. Shadowing. It is not there in other languages. The concept called shadowing. We also come out with the different data types available in the Rust language. The different data types available in the Rust language. See, we discuss what is called integer overflow, etc. So these are all some minor points that we are discussing on the Rust programming. So we'll come with serious, more elaborate programs. But and along with these all these concepts, we have included lots and lots of programs also. You can go through those programs. Each concept is associated with a number of supporting programs also. So you go through the programs and then you please do it as I directed in the earlier chapters. The installation part I have already described in the earlier chapters. So you please check, rather test each and every program that I have given in the course. That's very important. So now it's time to go into the actual video. Good luck. Part 2. Part 2. Variables and mutability. Variables and mutability. By default, variables are immutable in Rust. Variables are immutable in Rust by default. This is one of many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. Full stop. However, you will have the option to make your variable immutable. Full stop. Let us explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. You might want to opt out. Full stop. When a variable is immutable, comma, once a value is bound to a name, you can't change that value. You can't change that value. Full stop. You can make them mutable by adding mut in front of the variable name. In front of the variable name. Full stop. In addition to allowing this value to change, comma, mut conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable value. Will be changing this variable value. Full stop. The example code in the programs discussed below illustrates this concept. Full stop. The slide immediately after this shows our first program in Rust. The slide immediately after this shows our first program in Rust. We use the Eclipse IDE as our development environment here. We use the Eclipse IDE as our development environment here, full stop. We can similarly use the Guinea IDE also. We can similarly use the Guinea IDE also. Both are great. Both are great. Yeah, we are now coming out with our first program from Rust.
our first program from Rust. Look, we are using the Eclipse IDE. As I told you, this is one of the most elegant IDEs on earth. This IDE is from Eclipse Corrosion. Look, I have already given you the details of how to download Eclipse Corrosion and install everything. Previously, I have already given all the details. All the details of installing Rust and other softwares necessary for running the Rust programs. Everything I have dealt in detail in the previous sections. Okay, fine. Now look, we are now coming out with our first program. A simple program. So in order to create this program, you have to create a project. Okay, you know it. That mechanism is very simple. Look, you go to this file, just go to new, then click this project. Click this project. Don't worry. So, and see, it has got general, C, C++, etc. Rust. In Rust, you just click, and this cargo project. You just click cargo project. Then see, double click it. Double click that cargo project. You got the point? See back. This is the cargo project. Double click that. Okay. This window will come. Everything is there. By default, your project name will be available in the workspace. See, it is actually, see, new underscore Rust underscore project underscore 1, like that. Okay, fine. It will come automatically. It will come. Then you just click finish. So that project will be created. Okay, fine. It's that very simple. Creating a project is that very simple. I'll just cancel it. Okay, I think you got it. So you don't have to give any name. Automatically the name will be, the project name will be given. See new project, new underscore Rust underscore project underscore 1. So like that, the next project will be underscore 2, and the next project will be underscore 3, etc., etc. It will go. It will be available in the typical workspace, the Eclipse workspace. That also I will show you. So I am just closing it. Okay, you got it? I think it's very, very simple and clear. Now look, it will be available in the, see, I will show you. Yeah. We'll go to see always it will be in users. The Eclipse will be installed in users, comma, in admin. Users admin. Okay. In users admin, just go and check. This is the Eclipse. So I have so many Eclipses in my system. So different Eclipses I have. So I have, for this Rust purpose, I have made this workspace as, see, Eclipse workspace Rust. I have given a name for that. So my workspace is actually Eclipse workspace Rust, so that only my Rust program projects will be available in this directory. Just double click. Yeah, so much of projects I have done. I have done around, see, 190. See, it's 190. Okay, so fine. Like that, you see, each project is, will see, new Rust project new underscore Rust underscore project underscore 1. Next, new Rust project underscore 2. New underscore Rust underscore project underscore 3. Like that. It will automatically be incrementing by 1 and like that. So you don't have to do anything. It is all created automatically. Fine. So it will be available, see, where? In admin Eclipse workspace Rust. This is entire projects will be available like this. It's very simple. So now, yeah, admin, users admin. You know all those things in Windows. It is users admin. Yeah, I thought I shown you. Go. As I told you, this is my workspace, Eclipse workspace Rust. So when you are installing Eclipse, you get the option to change the name of the workspace. You just make a feasible name like this. If you have so many Eclipse, if you don't have any other Eclipse, you not make any specific name, only Eclipse workspace, it will come automatically. You need not change the name to Rust. Okay, it's all left to your, so as I told you, I have so many, around 190 programs I have done for this course. I have done around 190 projects. Okay, fine, that's all very, very simple. Now I think I will stop that. So this is how we are creating a new project. Okay, fine. So that is this. See, it is there. New underscore Rust underscore project 1. Project underscore 1. Fine. So this is the program. Very simple program. See, FN. FN for function. Main. Look, everything is in small lowercase letters. Main. The main function. See, FN is in lowercase. FN for function. Main. Function main. It has to be like this. Then there is an opening brace next. This opening brace can be either on the same line or next line also, no problem. See, so FN, main function, then open the brace, fine. On the same line, it's always convenient that it will be on the same line. Next. This is a very little bit funny. Print ln, there is an exclamation mark. Look, it's very important. PRINTLN, print ln. Then there is an exclamation mark. Actually, this particular syntax, this is called println macro. We call it as println macro. We don't pronounce it as println exclamation. That's not the way. It has to be pronounced like println macro. That means println, then there is immediately after that, there is an exclamation mark like that. So it's normally called as println macro. So then in bracket, this string I have passed, hello world, comma, welcome. It's a string. Close the bracket, semicolon. One more, again, println macro in bracket, within double quote. Welcome to the Rust IDE. Again, double quote end, then close the bracket, semicolon. Fine. These are all simple strings. Okay. Again, println macro in bracket, within double quote. This ID is from Eclipse corrosion. Again, that much is within double quote only. Close the bracket, semicolon. Fine. So after each program statement, you have to keep the semicolon. It's very important in Rust. Then after that, next line, keep the closing brace. This is the closing brace. Finished. The first program is that simple. We have just finished it. There's nothing great in this. Okay, we'll just save everything. Save everything. Just, before that I will clear it. No problem. Even if you don't clear also, no problem. Look. Then this is the run icon for the run project. Just you click run icon. Run new underscore, our project name also has come. See, if you click run new underscore Rust underscore project underscore 1. So our project name has come. Just you click it. Yeah. Hello world, welcome. Welcome to the Rust ID. This ID is from Eclipse corrosion. This ID. So whatever string we have passed, it has come as the output. It is that very simple. This is that very simple. We will now come to an end. Yeah, this is our second program. Yeah, that is actually, this is our next program. Okay, fine. How we are going to create this project? I know for this program, again, you have to create a new project. For this program also, you have to create a new project. For that, just go to File, go to New, and Project. See, this window will come, small window. Then look, this cargo project. See, don't do anything. Don't put any names. Nothing you want. See, there is actually C++, general C++, Rust, in Rust only. So this is actually the cargo project. It's written as cargo project. So here you just double click. Okay. So this window will come. So this project, automatically the project has come. See, new underscore project. So actually it will come underscore 2 because this is our second project. Because we made the first project as underscore 1, new underscore rust underscore project underscore 1. So this will automatically come as new underscore rust underscore project underscore 2. It will automatically come, don't worry about it. So now look. So fine. So everything is so simple. This is the way that we are creating a project in Rust. Without a project, you can't create the program. So in that project, the src directory is there. In the src directory, we have got this rust.rc. Main.rc. Fine. In that main.rc only, we are actually printing. Yeah, we are writing the code. We are writing the code in main.rc. Everything is there. src is there. Main.rc also automatically has come. Just you write the code in this. Okay, fine. This is how we are creating a new project. Fine. I think it's okay. Now I will just cancel it. Okay, fine. Now look, this is the project. This is our program. We have created this project. See, new underscore rust underscore project underscore 2. This is the second. New underscore rust underscore project underscore 2. This is the next project. So in that project, we have this main.rs under the src directory or src folder. Okay. Now look, see, this is what we are writing. See, this program is, some comments I have put. Look at these comments. Variables and mutability. Variables and mutability. See, again, continuing our comment. By default, variables are immutable in Rust. It's a very important point. By default, variables are immutable in Rust. Full stop. You can make them mutable by adding mut in front of the variable name. See, that means if you are keeping the keyword mut in front of the variable name, that variable becomes mutable. That's it. You can make them mutable by adding the keyword mut in front of the variable name. Okay, fine. Following is an example on this. This is a typical example for that. This is a very simple example. Look, fn main. Fn for function, you know it. Fn is for function. Then main, main. So this is the main function. Now look, main function. Then everything is in lowercase. On the same line, we are keeping the opening brace. Next, let mut x is equal to 5, semicolon. See, we have to use the keyword let in order to declare a variable in Rust. So we are using the keyword let. Be very careful. Declaring a variable in Rust is with the help of the let keyword. Let, and as I told you, we are using the keyword mut in front of the variable x because we want to make it mutable. So that's it. So let mut x is equal to 5, semicolon. Okay, fine. Next, println macro. You know, it's println macro. Println, then an exclamation mark in bracket. We call it as println macro in bracket within double quote. See, the value of x is, there's a pair of braces like this. There is a pair of empty braces like this. Or there's a pair of empty brackets, curly brackets like this. The whole thing is kept within double quote. The value of x is colon, then a pair of braces. The whole thing is kept within double quote, comma x. Close the bracket, semicolon. What is the meaning of this curly braces? See, the content of x will come and sit inside this curly braces. This is actually a placeholder. This is called a placeholder. In Rust, this is the placeholder. So the content of x will come and sit inside the empty braces or empty curly brackets. Fine. For that purpose only we are using this curly brackets or braces like this. Okay, fine. That's very simple. Content of x will come and sit here. So the value of x is, it will become the value of x is 5. Look at the output. The value of x is 5. Next we are assigning the value of 6 to x. See, x is equal to 6. Semicolon. This is valid because we have made x as mut. We have used the keyword mut. So it's absolutely possible to assign a new value to x. X is equal x is equal to 6 semicolon. Semicolon is a must, you know it. Then println macro in bracket, again within double quote, the value of x is now, again that's placeholder, the whole thing is within double quote, comma x, close the bracket, semicolon. Fine, it's very simple, you know the meaning of all those things. The value of x is now, the pair of braces, the whole thing is within double quote, comma x, close the bracket, semicolon. Fine. Then see, this is the closing brace for the main function. This is the closing brace. Everything is okay, fine. The program has come to an end. The program has come to an end. We will just go and save everything. We saved everything. Just we click this run icon. See, run as. Just you click. Then you will get, see, cargo based Rust project. Cargo based Rust project. Click that. Then click OK. Yeah. The value of x is 5. The value of x is now 6. That's exactly. The value of x is 5. The value of x is now 6. Very simple. The output has come. Perfectly all right. See, it is that very simple. Look. So this is our program on variables and mutability. Keep in mind the usage of the mut keyword. Fine. Now we'll come to an end.
Yeah, difference between variables and constants. We are discussing the difference between variables and constants. Being unable to change the value of a variable might have reminded you of another programming concept that most other languages have. See, it's nothing but constants, full stop. It is nothing but constants, full stop. Like immutable variables, comma, constants are values that are bound to a name and are not allowed to change, comma, but there are a few differences between constants and variables. There's in fact a few differences between constants and variables. Yeah, look, first, you are not allowed to use mut with constants, full stop. Constants are not just immutable by default, they are always immutable. They are always immutable. Fine, full stop. You declare constants using the const keyword instead of the let keyword, comma, and the type of the value must be annotated, full stop. Just to know that you must always annotate the type. Fine. Constants can be declared in any scope, comma, including the global scope, comma, which makes them useful for values that many parts of code need to know about. Many parts of the code need to know about. Full stop. The last difference is that constants may be set only to a constant expression, comma, not the result of a function call or any other value that could only be computed at runtime, or any other value that could only be computed at runtime. That's it.
Yeah, we are coming out with another program on constants. Look, example on constants. So this program also, we have to, for this program also, we have to create a project. You know the process. So first thing is that you have to create a project and include this particular program into that project. It's a must. In every new program, we have to create an associated project. So now look, for that it's very simple. See, you go to File, come to New Project. Yeah, New Project. Look, don't do anything here. Don't put any name or anything here. See, General C/C++ Rust. In that, Cargo project is there. See, you just double click this Cargo project. Yeah, automatically the project name, everything will come under user /admin / Eclipse workspace Rust. See, it will come automatically in that Eclipse workspace, the name of the project. See, new, see, it is new _Rust _project. Now, this is the third one. So, it will come as _3, like that, _3. All those things will automatically come. You don't have to do. If you want to change, you can change the name, everything. But I am telling you the easiest way. See, just click, and you are getting the name of the project also by default. So this will be the third program. So it will come as new _Rust _project _3, like that. Okay, fine. I think it's very, very easy. And now we will just close it. So that is the way that we are creating a new project. Into that project we are writing this particular code. This is a very simple code. Look, that project, there is a src directory. In that src we have main.rs. rs for main.rust, main.rs. So that's it. In this main program, in this editor only we are writing the code. It's very, very, very simple program. See, example on constants. And one more point I want to, it will automatically be put in the Eclipse workspace. See, I will show you that. See in C, you just go where the, see, it will normally be put in usage. The Eclipse will be users in admin, users in admin. Okay, we'll come, see, Rust, Eclipse workspace Rust. Since I have got a lot of other Eclipses, I have very clearly mentioned Eclipse workspace Rust. See, I have so many of programs, around 190 programs I have done for this course. Around 190 programs I have done. All those things are in the same directory. Look, so new _Rust _project 1 we already did. New _Rust _project 2, that also we have done. _2, that also we did. Now we are doing new _Rust _project 3, like that. It comes, it automatically the number, everything will come. See, this is how we are creating the project in the Eclipse workspace. I think it's very, very simple and very clear to you. Okay, fine. Okay, fine. The admin, so in admin, users admin, where by default the Eclipse will be installed. Okay, fine. So that's all very clear to you. Now, look, we will go through the program. Very, very simple program. This is an example on constants. Use the const keyword for declaring constants. We have used the const keyword for declaring the constants. Use the const keyword for declaring constants. After that, look, we are starting the program. Fn for function, then main function, main. All are in lowercase. Then open the brace on the same line. Opening brace on the same line. It's best we can save one more line. So keep it on the same line. Then look the way how we are declaring the constants. Const, the keyword const. The name is user _limit, user limit. Now look at colon. Look, a colon is put, then the type I32. This particular constant is of type I32 is equal to 100. Initialized with 100 is equal to 100 semicolon. Very simple it is. Please note that the name of the constant may be kept within uppercase like this. It should be kept in uppercase. We always use uppercase for making a constant. Constant names are always kept or put in uppercase. The type you can put after a colon, you can give the type. And what is I32? It is initially 100 semicolon. Declare an integer constant of type I32. That is the meaning of it. It's an integer constant of type I32. I32 is 32-bit signed integer type. You know all those things. I32 is nothing but 32-bit signed integer type. Had it been unsigned, it should have been U32. You know all those things. Fine. Next. So this is its value is assigned with 100. After that, semicolon. Fine. So it's very simple. See, the type you can put after a colon, you can just mention the type. I32 or U32, whatever you want. Fine. Now look, next, const pi value, pi, the pi value. Again, colon, F32 is equal to 3.14, semicolon. 3.14, semicolon. Look, pi, pi, colon. We have put a colon and then the type we are putting, F32. That means declare a float constant of type F32, 32-bit floating point. Declare a float constant of type F32. Fine. F32 is 32-bit floating point type. A 32-bit floating point type. Okay. Everything so. So declaring the type etc. is very simple in Rust. Just put a colon and give whether it is I32 or U32 or F64 or F32, whatever matter. So it's all a matter of just putting a colon and then keeping the type like this. So const pi colon F32, the type is F32, is equal to 3.14 semicolon 5. Everything is very simple. Now println macro in bracket. User limit is, after that this pair of braces or pair of curly brackets like this, empty curly brackets. The whole thing is kept within double quote, comma, user limit. So the content of user limit will come and sit in the empty brace. That is, so we call this empty brace. The pair of empty braces are called as placeholder. It's called the placeholder in Rust. So within double quote, user limit is placeholder. The whole thing is within double quote, comma, user limit, close the bracket, semicolon. Display value of the constant. Fine. Next, again, println macro in bracket. Within double quote, pi value is a pair of braces. The whole thing is within double quote, comma, pi, close the bracket, semicolon. That's all. The value of pi will come and sit in this empty brace. And it's very, very simple. See, then next, close the brace. This is the closing brace of the main function. This is the closing brace of the main function. So now look at the, so now everything is fine. What we will do is we will save everything. We'll go and run this run icon. We just click. Yeah, this will come. Cargo based Rust project that you have to tick. Then okay, fine. Yeah. User limit is 100. Pi value is 3.14. User limit we actually initialized with 100. So user limit is 100. Pi value is 3.14. See, everything is very simple. It is that very simple. I think it's very, very clear to you. Now we will come to an end.
Yeah, we are now discussing a concept called shadowing. It is what is called as shadowing. Fine. Very simple it is. Look, you can declare a new variable with the same name as a previous variable, comma, and the new variable shadows the previous variable, and the new variable shadows the previous variable, full stop. Rust programmers say that the first variable is shadowed by the second, comma, which means that the second variable's value is what appears when the variable is originally used. Simple, full stop. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. See, the following is a very simple program in Rust. We will have more elaborate discussions on the mechanism of writing a program in Rust. For the sake of simplicity, just you see that this is a very simple program. By looking at the very coding, you can understand each and every line. I'll have a very elaborate discussion on how we can write the programs in Rust. Now let us just discuss this. Fn is for function. Main. See, it is small letter main. Small letter main. So function main. That is the main function. Okay, open the brace. Like in any other language, open the brace. Then look, let x is equal to 5, semicolon. We are assigning the value 5 to x. So we are using the keyword let. Let x is equal to 5. Next, let x is equal to x plus 1. We are incrementing x by 1. So again, that value is assigned to x. Let x is equal to x plus 1. Now x becomes 5 plus 1, 6. Now again, let x is equal to x star 2. We are now multiplying the present value of x with 2. So now x value is 6 multiplied by 2. It will be 12, 5. Let x is equal to x star 2, semicolon. So semicolon is needed. Then print ln, then there is an exclamation mark. Look, print ln, an exclamation mark in bracket within double quote. The value of x is, the value of x is. Then there is a pair of braces, a pair of braces. Then that much is within double quote. The entire thing is now kept within double quote. The value of x is, put a colon like this. Then there is a pair of curly brackets or braces, and after that, see, the the quotes are ending at this point. Then put a comma. After that, x, close the bracket, semicolon. So the value of actual value of x will get replaced within this pair of curly brackets or within this braces. So that's what you should understand. The actual value of x will get replaced inside this pair of curly brackets or braces. Fine. It's very simple. Then last, this is a closing brace. Next is the closing brace. Fine. So the output will be the value of x is 12. The value will be, the output will be the value of x is 12. It's a very simple program. We will have elaborate discussions of how to write programs. We are actually using the Eclipse ID. Okay, we will come to that later. Now, just this is a very simple, this very simple concept. So the output will be the value of x is, so the value of x 12. Fine.
Yeah, we are now discussing the concept of shadowing. Shadowing. Already in the previous slide, I have given you the complete details of what exactly shadowing means. So we are now coming out with an example for shadowing. It's very simple. So, for this program also we have to create a project. All those things well known to you. See, the process is very simple. Just to go to File, go to New, File, New, and then come to Project. Then don't do anything here. See, in Rust, this cargo project is there. You just double click. Yeah, the project is already created in its default directory. Okay, fine. It will be new underscore Rust underscore project underscore 4 it will be. Actually, it's the 4th project. Okay, fine. So it will be, it's that easy. Okay, fine. Now I'll just cancel it. Now fine. Okay, fine. See, so we'll just go through the program. Shadowing. Fn main function. Open the brace. Everything is in lowercase. Main is in lowercase. Fn is in lowercase. Fn for function. Then open the brace on the same line. Next, let x is equal to 5. Semicolon. Let x is equal to x plus 1. Semicolon. Next. So now x becomes 5 plus 1, 6. Next, let x is equal to x star 2. That is now 6 star 2. That is 6 multiplied by 2. That is 12. So print ln macro in bracket within double quote. The value of x is, there is a colon like this. Then there is a pair of empty braces. The whole thing is within double quote, comma, x, close the bracket, semicolon. The content of x will come and occupy the empty braces. in the empty, inside the empty brace, the value of x will come and occupy. Okay, then after that, finish. After that, close the bracket and semicolon. Next line, closing brace. This is the opening brace for the main function. This is the closing brace. Yeah, it's very simple. Now look, if you look at the output, the value of x is 12. The value of x is 12. So we have just saved everything. Just click it here. Yeah, the value of x is 12. It's that very simple. It's that very simple, you know. So it will be available in the Eclipse workspace. All those things I have explained to you. Okay, now we will just come to an end. We will close it.
Yeah, data types. We are now discussing what is called data types. See, every value in the Rust is of a certain data type, comma, which tells Rust what kind of data is being specified. So it knows how to work with that data. So it knows how to work with that data, full stop. We will look at two data type subsets, scalar and compound. The two data type subsets are scalar and compound. Keep in mind that Rust is a statically typed language, which means that it must know the types of all the variables at compile time, full stop. The compiler can usually infer what type we want to use based on the value and how we use it. Based on the value and how we use it. Full stop. Scalar type. Scalar type. Look, a scalar type represents a single value. A scalar type represents a single value. Full stop. Rust has four primary scalar types. Rust has four primary scalar types: integers, comma, floating point numbers, comma, booleans and characters. Booleans and characters. Full stop. You may recognize these from other programming languages. Let us jump into how they work in Rust. Let us consider how they work in Rust. Look, integer types. Integer types. An integer is a number without a fractional component. You know that. Without a fractional component. Full stop. We used one integer type, see earlier, the U32. The U32 type. Full stop. This type declaration indicates that the value it is associated with should be an unsigned integer. Should be an unsigned integer. Signed in bracket I have put. Signed integer types starts with an I. See, instead of U. U32 is because it is unsigned int. See, that's what very clearly I mentioned. Signed integer types starts with an I instead of U because U is unsigned. Fine, full stop. And that takes up 32 bits of space, and that takes up 32 bits of space. That's why U32, full stop. Table down shows the built-in integer types in Rust. Each variant in the signed and unsigned columns can be used to declare the type of an integer value. Can be used to declare the type of an integer value. Fine. Yeah, integer types in Rust. Integer types in Rust. We have here three columns. One column for length, another column for signed, and the last column is for unsigned. So length, signed, unsigned. Okay, let us say 8-bit. Length is now 8-bit. So signed is represented by I8 and unsigned is represented by U8. Next, 16-bit, I16 and unsigned is U16. Again 32-bit. I32 for signed and U32 for unsigned. Then 64-bit. I64 for signed and U64 for unsigned. Again 128-bit. I128 for signed and U128 for unsigned. See, there's another thing, see, length called arc, ARCH, arc. So I size for signed and U size for unsigned. We'll just tell you what exactly this arc and I size, U size, etc. Okay, fine. It's very simple to understand. So now look. So an I8 can store numbers from -128 to 127, and a U8 can store numbers from 0 to 255. You know all those things. 0 to 255. Full stop. Additionally, comma, the I size and U size types depend on the kind of computer your program is running on. It depends on the kind of computer your program is running on. Look, 64 bits if you are on a 64-bit architecture, and 32 bits if you are on a 32-bit architecture. This arc is for architecture. Look, that's it. 64-bit if you are on a 64-bit architecture, and 32 bits if you are on a 32-bit architecture. Fine. It's all very simple. Fine. We will now stop. Yeah, integer overflow. Integer overflow. Fine. Let us say you have a variable of type U8 that can hold values between 0 and 255. You know it. U8 can hold values between 0 and 255. Full stop. If you try to change the variable to a value outside of that range, comma, such as 256, comma, integer overflow will occur. Integer overflow will occur. Full stop. Rust has some interesting rules involving this behavior. Rust has some interesting rules involving this behavior. Full stop. When you are compiling in debug mode, comma, Rust includes checks for integer overflow that cause your program to panic at runtime if this behavior occurs. Full stop. Rust uses the term panicking when a program exits with an error. We will discuss panics in more depth in the coming sections. We will have an elaborate discussion on panics in the coming sections. Fine, full stop. When you are compiling in release mode with the -- release flag, Rust does not include checks for integer overflow that cause panics. Full stop. That cause panics. Full stop. Instead, comma, if overflow occurs, comma, Rust performs 2's complement wrapping. Rust performs 2's complement wrapping. Full stop. In short, values greater than the maximum value the type can hold wrap around to the minimum of the values the type can hold. Wrap around to the minimum of the values the type can hold. Full stop. In the case of a U8, in the case of a U8, comma, 256 becomes 0, comma, 257 becomes 1, and so on. Like that only. 257 becomes 1 and so on. Full stop. The program won't panic, comma, but the variable will have a value that probably is not what you were expecting it to have. Full stop. Relying on integer overflows wrapping behavior is considered an error. Full stop. If you want to wrap explicitly, comma, you can use the standard library type wrapping. If you want to wrap explicitly, comma, you can use the standard library type wrapping. Fine.
Yeah. Here is an example on integer overflow. Actually, I have given a greater explanations on integer overflow in the previous slide. A very elaborate explanation on integer overflow has been given in the previous slide. So here I am just showing two examples. This is a simple example. One more example, a more elaborate example, the next example. The next example is a more elaborate example. So all the details regarding the overflow mechanism and how to manage the overflow in Rust, I have explained in that slide. Yeah, then see, we can just go through it. It's very simple. Look, example on integer overflow. And by the way, you know the mechanism of creating a project. I don't have to again and again explain it. Anyway, I will just one more. See, go to file, then go to new, come to project. Yeah, don't do anything here. Just cargo project, double click. In Rust, cargo project, double click. Yeah, your project is created automatically in the default directory. See, new underscore Rust underscore project underscore 5. Yeah, it's here given as 5. Automatically the number also will be there by default. It is now 5th project underscore 5, like that. Everything will be so it's very simple. You follow this instruction. This is the simplest because the system itself will give a name for the project. Everything is that very simple. Now look, okay, fine. So now I'm just cancelling it. Okay, fine. And you know the mechanism of where this project is saved, how exactly where it is saved and all that. It is actually saved in the users admin Eclipse workspace directory. All those things we have discussed several times. Okay, fine. Now just we will go through this. Example on integer overflow. Now look. An integer overflow occurs when the value assigned to an integer variable exceeds the Rust defined range for the data type. That's very simple. The Rust defined range for the data type, full stop. Let us understand this with an example. Very simple it is. Fn, function main, all lowercase letters. Then on the same line open the brace. Now look. See, there is a very specific statement like this. See, hash not within square bracket allow in bracket overflow literals close the bracket, again square bracket close within square bracket. This statement is a must. Look, I very clearly mentioned suppresses all warnings from class which overflows. Which overflow. That is, suppresses all warnings from class which overflows. So this statement is needed to suppress warnings. If you don't have this statement, there will be series of warnings and the program will not work properly. So okay, so keep this particular statement. Okay, fine. Next, let E colon U8 is equal to 300 semicolon. So this is it's a unsigned int 8 only. It is a 8-bit. It's a 8-bit unsigned 8-bit. You know it. Unsigned 8-bit number. So it's the maximum range, 0 to 255 and all those things. So let E colon U8 is equal to 300. We have assigned it to 300. Obviously, there is overflow. See, you can change it to other values like 255, 256, etc. and see the result. Actually, I have done it in the next program. So I am not showing it here. Again, println macro in bracket within double quote, the placeholder, comma, E. Then close the bracket, semicolon. E is the variable, name of the variable, E. That's actually assigned with 300. Look, println macro in bracket within double quote, the placeholder. That is, placeholder is nothing but a pair of parentheses, empty parentheses. Oh, sorry, empty braces, not parentheses, empty braces. Absolutely not parentheses. It's a pair of braces or a pair of curly brackets. Pair of curly brackets. That is the placeholder in Rust. Empty curly bracket. So that is, we have kept it with the double quotes, then comma, E, close the bracket, semicolon, fine. Next, this is, it is actually the closing brace. This is the opening brace for main, and this is the closing brace for main. Now look, you can save everything, and you just click this run icon. The output is 44. The output is 44. I have explained all the details in the previous slide. How you get 44, etc. How you will be see from you can check it with other values like 255, 256, etc. So go through the slide again and understand the logic I have explained in the slide. So the program is absolutely simple. Now one more program from the same area, example on integer overflow, I am giving in the next program. That also is absolutely similar only. Okay, fine. I think it's very, very simple. And we will now come to an end. Our answer is 44, you know it. Yeah, another example on integer overflow. One more example from integer overflow. Before entering into the program, we will again discuss how to create a new project. You know it very well, but still I am just giving a hint. Go to File, New and Project. Okay, you will get this window. Don't do anything here. Just see General C/C++, then Rust, this cargo project. You just double click on cargo project. Okay, this window will come where your new project will be automatically created. Look, see, new underscore Rust project. It will be _6. It will become _6 because this is the 6th project we are doing. Okay, and all those things are happening in where in users admin, Eclipse workspace, all those things, you know it. Users admin, Eclipse workspace is the default directory where these projects are saved. Okay, fine. It's all very simple. Okay, I think this is a simple process. Now I'll just cancel it. Now we are coming to the program. It's very simple. Another example on integer overflow. Now look. An integer overflow occurs when the value assigned to an integer variable exceeds the Rust-defined range for the data type. You know it. I have explained it in the previous program also. Full stop. Let us understand this with the following example too. We are considering one more example. Fine. In this is a little lengthier example. Don't worry. Absolutely same thing only. Fn main function. Look, Fn for function, main, lowercase main function. Then open the brace on the same line. Now look, this is a statement. Hash not within square bracket, allow in bracket, overflowing underscore literals. Overflowing literals, close the bracket, close the square bracket. Very clearly I have mentioned, suppress all warnings from class which overflow. And then this statement is needed. This particular statement is needed. I will give you more explanations on that. See, here it is here. Look at the contents inside the square brackets. The contents inside the square bracket. Allow in bracket overflowing underscore literals. That is in bracket. This is what is available in the square bracket. Okay. Okay, now look, we'll just go through it. Look at the contents inside the square bracket after the hash not symbols. There is a hash and a not symbol. Has not symbol. Hash not symbols, full stop. This is actually turning the overflowing literals lint from want to deny mechanism followed in Rust language to block the warning messages that occur on the so-called integer overflow. It's very clearly written. See, this is actually turning the overflowing literals, lint from one to deny mechanism followed in the Rust language to block the warning messages that occur on the so-called integer overflow. Full stop. Very clear. That's why we have mentioned the hash not. Okay, fine. Hence, once you keep the above statement before the declaration of the integer variable, comma, the program will work properly. And come out with the proper output. Fine. Otherwise, there will be only warnings and the program will not compile only. So this is a very important step that you have to keep when you are handling with the overflowing integer overflow programs. This particular statement is a must. Okay, I think I have explained it very well. So that's why this statement is needed, I have said. Okay, fine. Then look, we are now declaring some typical variables of type, see, integer type, unsigned int only. See, let age U8 is equal to 255 semicolon. One variable is by name age. It's of type U8. Unsigned int, it's an 8-bit. What is the range? 0 to 255 is the range of U8. You know it. 0 to 255 is the range of U8. You know it very well. Then, fine. Okay. So, we have now declared one variable by name age. Next. Yeah, I mentioned 0 to 255 only allowed for U8. Maximum allowed is 0 to 255 for U8. Next. Then let, again we are using the let keyword to declare the variable. Let weight U8 is equal to 256. See, overflow value is 0. Yeah, I have explained all the mechanism of overflow in the previous slide. You should go through, if you have any doubt, go through that slide and read it several times. So let weight U8 is equal to 256 semicolon. I have mentioned a comment. Overflow value is 0. Let height U8 is equal to 257 semicolon. Overflow value is 1. Let score U8 is equal to 258 semicolon. Overflow value is 2. Similarly, look, let marks U8 is equal to 300 semicolon. Overflow value is 44. Now look, then fine. You have declared a series of variables belonging to U8. Type is U8. Then println macro in bracket within double quote. Age is, after that the placeholder, which is nothing but a pair of braces or a pair of curly brackets. That whole thing is within double quote, comma, age, close the bracket, semicolon. Next, println macro in bracket within double quote, weight is placeholder. The whole thing is in double quote, comma, weight, close the bracket, semicolon. Then println macro in bracket, height is placeholder, again within, that much is within double quote, comma, height, close the bracket, semicolon. Then again println macro in bracket within double quote, score is the placeholder, that much is within double quote, comma, score, close the bracket, semicolon. Okay, fine. We have declared all those values. And initialized with proper values. Unite. We have seen it. Then again, finally, println macro in bracket within double quote, marks is placeholder, that which is within double quote, comma, marks, close the bracket, semicolon. Fine. Then up next, close the brace. This is the closing brace for the main function. This is the main function's opening brace, and this is the closing brace. And this explanation I already read to you. I already discussed it with you. It's very clearly I have I mentioned the entire mechanism of this blocking of warning to, so this is hash not within square bracket, allow in bracket, overflowing underscore literals, close the bracket, close the square bracket. This statement is needed to block the warnings. Okay, I have discussed all those things at great length, so everything is fine. Now, now look, fine, everything is fine. Well, now we will just save everything and just click this. Yeah, it's very simple. Now look, age is 255. There is no problem for age. It is 255. See, what you have mentioned for age is 255. U8 age 255. It will come as such. Because the range for U8 varies from 0 to 255. So there is no problem for age. Age is 255. We got that. But when it comes to the variable weight, which is 256, see, weight is 0, height is 1, score is 2, and marks is 44. I think the logic is very clear to you. If you have any doubt, you go and refer to the slide where I have explained everything. It's absolutely simple. The two's complement mechanism we are using. All those things are very simple. See, this is the power of integer overflow. The way how Rust is coping or managing integer overflow. Fine. I think it's very simple and it's a beautiful program. You go through it and understand the logic. And that's very fine. We will now come to an end. So the age is 255, weight is 0, height is 1, score is 2, marks is 44. Fine. Now we will come to an end.